Okay, so good morning. Good morning, everyone. So our next topic for today is about general curvilinear motion. But before we proceed with this topic, let's review some key concepts to the first topic, which is rectilinear motion. Okay, so previously we've discussed about the differences in distance, position, displacement, as well as velocity, acceleration, and speed. And then we went to different categories of motions. No, there is the most popular type of motion, which is constant motion, wala sa acceleration, ng constant lang speed in a straight line motion, muna siyang rectilinear motion. And then the second most popular is uniformly accelerated motion, wherein we have a constant acceleration. Bali, mayroon ka sa acceleration, meaning yung mga velocity ga increase or ga decrease, but constant ang iyang rate of increase or ang iyang rate of decrease, because nga ito, acceleration is constant. And for this type of motion, we have derived three equations now. And these three equations, if you can recall them easily na lang, you have to recall na lang them and use. Okay, para makasave the time. Unless you're going to derive them every time you solve the problem, then I think that's a waste of time. So first category, it's just simple v equals to x over t. Second, we have three equations for constant acceleration types of motion. And then for the third type of motion, we have what we call others, because in this category, there is not a single equation that can rule them all. The equations are unique for each behavior motion. Meaning you have to derive every time, you have to formulate the unique equations for that behavioral motion. Example, ini siyang last example, tas ang last two to bala. Kita ko lang sa ang last two tanga problems last time is nabilong nisa sa category 3 motion. Ini because ang aton displacement function is a function of time, and if you derive this one, dxdt, derive again, may mo siyang acceleration function. Ang imong acceleration function is not constant. Kita mo diyan siya. Ay siya. Ang iyang equation is acceleration equals to 6t minus 12. It means the acceleration time is dependent on variable time, which is t, meaning it changes. No? Meaning acceleration time is not constant. Therefore, it does not belong to category 2. It belongs to category 3, which means we have to derive, if we can, from the start using two fundamental equations, which is v equals to dxdt and a equals to dvdt. But in this case, ang x is defined na daan as a function of t. So dito mag-start from the scratch, which is dxdt of v, and the acceleration of dvdt. This is the fundamental equations, meaning by definition, velocity is the rate of change of displacement, and by definition, acceleration is the rate of change of velocity. This is the most fundamental, meaning it applies to all. But if the specific function is already defined, in this case, displacement is a function of time by this expression, then we have to take a different route, which is we have to derive it to get the velocity equation, then we have to derive it again to get the acceleration equation. Both methods work just fine. Okay, it happens na area ang displacement is defined na madaan explicitly by the variable time, whereas if ano if wala, then you have to still use this one. Example for that is ang atong last example. Ano siya nga type. Ay, wherein ang given is that acceleration is a function of velocity, and then we apply this fundamental equation which is acceleration is equal to dv dt. In-equate na lang siya sa diri para ma-integrate siya. And then after that, nakuha ang velocity function. Ano siya ang velocity function? Ano siya? Velocity as a function of time. And then using another fundamental equation which is array, although technically this is not fundamental gain because it is derived using v equals dx dt and v equals a equals dv dt. In-divide mo lang ang diwana, nangin mo na siya a dx dv, but it is handy lang na gamitan ka siya na differential equation. From here, nakuha ang displacement equation, which is a function of velocity. So we have now displacement equation. So we have velocity equation as a function of time. They originate using the fundamental equations because experimentally they found out that acceleration is given by this expression. Then ginapply lang nila ang differential rules to get the equations. So if you want to recall this type of example, you can rewatch na lang sa previous na video. Okay, so it's important to master the previous I think wala ko na record, my god. Oh, yes, na-record ko siya. Thank you. Stop recording, pause recording. Okay. So, I'd like to iterate now that the concepts in dynamics is building upon the previous topic. So, it is important to master almost 100% the previous topics because ang mga ganito, nag-accumulate ang concept ng foundational siya. Dapat i-master siyang previous. That's why gin-record ko siya. Tapos proceed na sa next topic. So hopefully nag-gets na ang pinaka-main idea sa rectilinear motion, especially velocity and acceleration in straight line motion. Now, we applied these same concepts in 2D na galing. Bali, previously ay isa lang axis of motion. Ma-add ka another axis of motion, meaning nag-move siya in plane. Okay? So that's for the topic for today, which is the general curvilinear motion. So first, start as a general curvilinear motion, and then uniform circular motion, and then this special type, which is the projectile motion. So, general curvilinear motion. Let's say this is our most popular coordinate system, Cartesian coordinate system, or the rectangular coordinate system, x and y, and the origin. And this is the path of the object in motion in plane. Say, so initially, our object is at this point. Then finally, it is somewhere here. The position of the particle at the initial time is this. Remember that position is a vector, meaning it has to have an arrow. Okay, so this is, let's say, r, the position. of the particle. Let's call this point P, and this point P prime, that's the new position of our particle P. And so this position is R prime. So this is the final position, the R prime. R is the initial position. We know that the change in position is known as the displacement, correct? Previously, recall that displacement x is equals to final x initial minus previous x. Final position along x-axis subtracted by the initial position along x-axis. But this time, since we are using two axes, orthogonal axes, happen that displacement now is not x but delta r is equals to r prime minus r. R is composed of two vectors, which is along x and along y, but we can write it more than I, very simple now, which still captures the idea that the displacement, in this case delta r, not delta x, is equal to the final position r prime minus the initial position r. And ang itsura yan sa primero to. If this is our origin, this is our initial x, this is our initial final x prime. Mamaya ito na x, mamaya ito na x prime. The minus of that is this. Sa atin na x. In this case, ang muna Japan, diri ho nag-overlap ang ato ng mga vectors because uni-axis ta. Subong, it forms a triangle na. Kari na subong ato nga delta r. This is our delta r. Though similar kita nga, nag-ano na siya, nag-form na sa triangle. So this is our final position minus the initial position equals the displacement r, which is the change in position. That is the change in position, delta r. Now, since we also tackle the difference in the average velocity, the average instantaneous velocity, and the average acceleration and instantaneous acceleration, we know that average is approximation, meaning you have only 2 points, the final and the initial state, whereas instantaneous velocity or instantaneous acceleration, you have the behavior of the motion, meaning you can predict at any given time what is the velocity and what is the acceleration. Those are exact because they came from differential equations, while average, they came from statistics. Ano final, ano initial, boom, we get the average velocity, we get the average acceleration. Now, if we divide delta r by the corresponding delta t, what we get is the average velocity, because again and again, ang hint that there is delta, and delta means change. And change, so mathematics, is formally described as final minus initial. So if we take delta r and divide it by change in delta t, this is still called average velocity. Remember that. Average velocity because you have only 2 points. But if we set the limit of delta t as it approaches time, then our delta r also approaches a zero value. And the limit of this, the limit of delta r and delta t as delta t approaches zero is equals to dr dt, and that is instantaneous velocity. So recall again that in uni-axis, our instantaneous velocity is dx dt. Now, our instantaneous velocity is dr dt. Okay? So that's one of the differences uni-axis 2D. Right. So let's continue. That's for the velocity. Let's draw another. the same level. The same. Let's say this is the initial position, second, third, fourth, fifth time. Okay, these are R1, R2, R3, R4, R5. And our velocity by this, kung kita mo sa draw, kung nagagamay ang yung mga delta P, ang yung mga delta R, which is second, nagagamay mo sa nagagamay until ng imong second, ng tangent na sa. Therefore, the velocity vector is always tangent to the path. Makita taman di sa angle D. One of the key points here is that velocity vector is always directed tangent to the path. Okay, makita ta sa aton nga thought experiment di kung pagamayon ang angle between the final position and initial position, we see that the second becomes tangent to the point of the initial head of the initial position. Excuse me. Now, so this must be tangent. And this must be tangent. Again, this is tangent. Again, then tangent. This is the path of the object, path of the motion, path of the particle. The velocity is tangent to the path. What about acceleration? Acceleration is not tangent to the path. If we take these velocity vectors and graph somewhere, let's say ini nga vector sa say ini siya niyo, tapos ini naman siya ni, ini naman siya ni, and then ini siya ni, then last siya ni. This is known as the hodograph. Dirakyat tangent ang ato na acceleration. Very acceleration. A1, A2, A3, A4, A5. Whereas 3 R1, R2, R3, R4, R5, V1, V2, V3, V4, V5. Okay. So remember that the velocity vector is tangent to the path, while the acceleration vector is tangent not to the path but to the hodograph. The hodograph is not an actual thing. If you make this graph, then imaginary lang siya curve, but tangent ang acceleration. So how do we make sense of this? Nga amo na ang velocity tangent sa path ng acceleration niya. How can we explain this one? Let's go to velocity and let's expose the components. Let's say we have a path again, pero i-show talaga niya say this is the path of motion. Here we have our object at that instant. Since it is tangent to the path, then I have to draw tangent to the curve. This is our velocity vector v, and of course its position is area. Now, this is x-axis, this is y-axis. Now I have to expose the the component rather. This is Vx, and this is Vy. You see that Vy is going 1 more and Vx is going right. The velocity V vector is equals to J, and the magnitude of the velocity is equals to square root of Vx squared plus Vy squared. That's for the velocity. Sa baba, kung naman sa Japan, galing, wala talagang expose ang position. Diri, yung part, drawing ko lang siya sa dalawa, para tingog. Oops. Our position R also has components. So our R is equals to Rxi plus Ryj. And the magnitude of R is equals to Rx squared plus Ry squared plus Z. If maganda na tayo sa 3D, then butang ka lang Z. And the corresponding unit vector for Z is K. So attach ka lang that VZK. RZK. But dran sa dyan sa 2D lang. Now, what is velocity? Velocity is a vector. And when you say vector, it has direction. And not only that, it has also magnitude, correct? Isulot ang concept ng acceleration. Isulot ang concept ng acceleration. Para mag-gets ito nga, mo ang behavior sa acceleration. Velocity is equals to magnitude and direction. Magnitude and direction. And acceleration is the rate of change of velocity. Acceleration is rate of change of velocity. Meaning, ang velocity is composed of magnitude and direction, while acceleration is defined as the rate of change of velocity. Meaning, once may change of velocity, there is acceleration. So, ano na silang mga changes na? Isa-isa on track. Once constant ang magnitude, once constant ang direction, meaning straight line ng motion. Pero nagdasi siya, naghinay siya, then there is a change in magnitude, but not in direction. There is a change in magnitude, therefore, there is acceleration. By definition, basta may change sa velocity, there is acceleration. And what type of acceleration is responsible for change in the magnitude? It is called tangential acceleration. Tangential acceleration. Why is it called tangential acceleration? Because ang change lang, hindi yung magnitude, hindi yung direction, hindi magnitude lang. And we know naman that velocity is always tangent to the path. Kung naggamay niya siya, kung nagdako na siya, it is still always tangent to the path. And that type of acceleration responsible for a change of that length or that magnitude is what we call the tangential acceleration. Next, what if constant at magnitude? Pero the change in direction, let's say, I can drawing ko diyan. Ga-travel dito sa inyo. Let's say, ikat ko sa El Salvador. I-curve na ganggalan. Constant mo yung speed. Constant mo yung speed. Pero naka-curve ka din. Constant mo yung speed, pero naka-curve ka, meaning the change in direction. Therefore, ang velocity is still changing. Yes, constant yung mga speed, pero ang velocity mo yan, because velocity is speed and direction. Ang direction mo nag-change, ang speed mo constant. Therefore, there is still acceleration. And what is that type of acceleration? That is not tangential to the wall. Gamit siya na yun. It's for the time being, let's call it normal acceleration na yun. normal acceleration. Right? That depends sa type of axis. So, normal acceleration is responsible for direction, change in direction. Wala pa to. Tangential acceleration is responsible for change in speed. Padasid pa siya. So, in this case, makita ko yun. Naka-curve ato na path. Let's say ang atong velocity is, ang atong speed is constant. Then, you can then say, change in direction, therefore, mayari niya sa normal acceleration. Bistan constant pang iyang speed along the path. Mayari niya sa normal acceleration. Why? Because there is a change in direction. Ang path is curved. Obvious kita, common sense. Ang tangent hindi mo na makita. Ang tangential acceleration hindi mo na makita. Pero sa drawing yan, kita mo sa okay. You change in direction therefore may normal acceleration. Now, since velocity is tangent, acceleration is not always tangent. Unless straight path. Let's say, we have a very long path. Our particle starts here. Velocity v1. Paglapit siya, nagdasig siya. Grabe. Dito na si Brisa. Paglapit siya, nag-hinay siya. V3. Okay. Straight line. We have changes in velocity. Therefore, we have tangential acceleration. Because nag-change siya ng magnitude. But since the path is straight, therefore, the normal acceleration, which is responsible for the change in direction, is 0. Notice mo kung ibutan ko din acceleration. Kung i-drawing ko din acceleration. Di ba, ari gamay. Ari ito po. Therefore, acceleration today. Acceleration today, let's say, drawing ko lang somewhere rin yun. Kung ano yung acceleration to. Tapos 3, since hindi gamay 3, therefore acceleration na is opposite. Now acceleration mo, flip lang, umama na siya along the path. Pero wala siya ga-awas din. Wala siya ga-3. Wala siya malaw. Because kung mag-amo na siya, it means ginpatiko yan ang moving object. Wala ginpa-change. Why lang ginpa-change in magnitude, but ginpatiko pa din. Dito, kita dito. Huwag mo na ito yung path. Huwag mo na ito yung velocity. It is always tangent. This is velocity. Ang acceleration niya, matangent na siya, pero is along. But it is always inside the curve. Ari siya, very important. Ang acceleration. Ang acceleration mo. Very probably ano siya, inline siya. Very ano siya. Siya always siya pasulod sa curve because it is trying ganit to change the direction. Ang maraming properties ng acceleration niya, it is inside of the curve. So that's the general property of general curvilinear motion with regards to velocity and acceleration. Their properties. These are important, especially when analyzing dynamics problem. Now let's go to 2 special cases of general curvilinear motion. First, a uniform circular motion. Uniform circular motion. This is a special type of general curvilinear motion. So uniform circular motion is obvious. Uniform means the magnitude. Circular motion means the path. I have to draw lang quarter of the circle lang. See, this is the x. This is the y. Our object, let's say, starts from the top, then it rotates in clockwise direction. Constant magnitude because uniform. So, ito siya. And then, pungaw ko lang sa 3. Ano na siya? 3. Ano siya? 3. Ano siya? And 3. Ano siya? So, this is a uniform circular motion wherein our object is rotating in a circular path and has a constant magnitude. So what can we derive from this? What can we draw conclusions from this? First of all, our position, which is the radius, is changing, but the magnitude is not. We have here our R, still our R Japan. The magnitude is constant. Magnitude is constant. But of course, the R itself is not there. We change yung components. We change here X and Y. And since velocity is equals to dr dt, dr dt, and it is tangent, then our velocity is just rotating along the path of the circle. Velocity is also equals to omega times r. Omega times r, wherein our omega is the angular velocity. Ano pa yun? You can also express that in r omega dot. What can we say something about this uniform circular motion? Acceleration before I forget. Since uniform circular motion, therefore the magnitude is constant, but the acceleration is constantly changing. Therefore, the tangential is zero. Tangential is zero, so wala yung mag-change ang length sa velocity, wala yung mag-pedasi, wala yung mag-percent. But our normal is not zero. And by definition, sa normal acceleration, which is the velocity squared over r, our normal acceleration in uniform circular motion is equal to v squared over r. It can also be called centripetal. Centrifugal is, I think, going outward. Centripetal is going inward, if I'm not mistaken. This is our normal acceleration. This is our velocity. And if we draw the normal acceleration in this, pwede ko na ma-change ang color. Pwede ko i-change ang color. Normal acceleration, kasulod siya. Kasulod. Mga ito na AN, mga ito AN. In this case, the acceleration, which is normal acceleration, is responsible for constantly changing the path and making it circular motion. Kumbaga, constant ano siya, kung wala lang isang normal acceleration ang object mo, if suddenly bimauntap niya, may exist siya, ang velocity niya mag-go lang siya pato. Mas sige lang siya dati raw. If there is a presence of forces somewhere else, say dito, that's why ma-change siya path. Ma-change na naman siya. Pero sige, change naman siya. Sige. So, this is isang example sa orbital mechanics pala ang moon or satellites na rotate around the Earth na hindi sila kadagdag, always lang sila rotate. As the sound velocity, gamay. Meron naman sa velocity yung may pasunod. So, mali yung mga final velocity. Yung sige-sige sa iba. Okay, so for i-recall ko na lang ang set of equation for general curvilinear motion, which is angular. Recall that our equation last time is plus minus 2as b minus v0 plus minus gt, and then s equals to v0t plus minus gt squared for uniform constant motion. Pwede rin siya ma-apply sa circular. Is lang talaga sa omega squared minus b squared plus minus 2 alpha theta omega minus omega plus minus alpha t, then omega t plus minus 1 half alpha t squared if the type of motion is given in angular.